No, not yet.
Okay. Can anybody else help me confirm? Can you see my screen? How about now? Can you see
On
my
my side,
screen?
I think it's still showing. I can't see it yet. I don't know whether it's my
No.
network.
Oh,
Me, I
okay.
can
Let me.
see. I can see the
What
Oh,
you
screen.
can
okay.
I
see.
can see it. I guess it's their network.
Oh, okay. 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 Please let's take time to see now if we can see the screen.
I can see the screen from my.
Oh, okay. Thank you,
Yeah, I can
Gabi.
see.
Okay. Okay. Thank you. All right. So the first thing I'm going to do is I'm going to share the brief with us. Basically, the brief contains for the project we're going to be working on next week too, is going to come with a brief. So this brief contains an overview of the data set, It's an employee data set. There's a data set preview of all the columns within, and also I'm going to open a preview of the data using Excel. So this is what the data looks like in Microsoft Excel. You can see this is a preview of the data here in Microsoft Excel. Now, first things first, I mentioned before during the last class that all the things that we've learned, the essence of this project is to now be able to put them to practice. So we're going to be using all of these 15 questions to write queries. But first step has to be to understand the data set. So this is going to be our final project, and we're going to be analyzing the data at Splendor Investments. In this project, we work with a comprehensive data set containing detailed information about employees within the company. The task is to leverage SQL to explore and analyze the data set and extract insights to aid the company in understanding the company workforce better. Now, for this, we are going to be using these questions. So let's go to SQL, and the first thing we're going to do is to create a database that we're going to load the data set into. And to do that, I'm just going to right click on databases, new database, and I'm going to name this database employee DB. So DB being an abbreviation for database, not necessarily because you have to, it's just something that I do often. And I'm going to create the database. Now, having created the database, the next thing we're going to do is to bring in the data set, that is to load in the data set as a table. So we open the database, and then on the tables, for our tables, we're going to then click on the database, right click on the database, and then come to tasks. After we click on tasks, we're going to say import flat file. Now, the only reason why we can import a flat file is one of these two options. Is either your file is in a CSV format or in TXT format. That's when we can import the file into SQL and say, okay, yeah, this is what we work with. So the file we're going to be working with is already a CSV file. So most times, if you get the data in XLSX, it's a lot faster to just convert it to CSV by saving it as a CSV file in Excel and then loading it into SQL Server. Now, I showed us this pane before when I showed us how to load in a data. I'm just going to walk us through it again. So we're going to click on next and then go open our local file manager to select where the file is. For this, I'm just going to select the file. Now, can you see that it's already showing here that it's a CSV file? Now, this is then going to, when you select the file, SQL Server is then going to try to name the table based on the name of the file. But what I'm going to, mind you, whatever the name of the table is called is what you are going to use in your query as well. That is for your from the name of the table. So for this new table name, I'm just going to call this employees. I'm going to call this employees. Now, then I'm going to press next. I'm just going to press next. Now, this DBO, I mentioned earlier on that whenever you create a table in SQL Server, it saves as dbo.the table name, because tables in SQL are called database objects, and that's why we have this here. Now, we're going to load this in, and then what SQL is going to do is that it's going to give us a preview of the data. It's going to give us the data preview. Now, okay, this is what I'm seeing. Just like Power Query in Power BI will give you a preview before you can decide to either load or transform the data. I hope we're still together. All right.
Yes, sir.
All right, can I proceed?
Yes, sir.
Okay. Now, when you see the preview of your data, the next thing you are moving on to is to demodify columns. Basically, what this allows you to do is to load in or change or check the data types of each of the columns. When we were starting the SQL classes, I mentioned that data types is an important part of databases. You cannot say you are maintaining or managing a database and you don't understand the data, the kind of data that is contained within the tables in that database. Now, what SQL will do upon importing that file is to automatically detect the data type that is most applicable for each column, or that is most suitable to each column. And if you want to change any of these data types, you can click on it. Just click on the data type dropdown and you'll be able to change the data type. Now, I want to mention that percentage is not a recognized data type in here. Percentage. So if you are bringing in a column that contains percentages, you are going to have to handle it as a varying character column. But I'm going to show us as we go on along the way, when we load in data and preview it, how we can still work with percentage inside SQL Server. So for this, I'm going to go back to preview data one more time to see the data preview. The data type for the employee ID, I'll change it to varchar because it contains text and numbers. So I'll change it to varying character and I'll press next. Now, this will then show you a summary of the action you're about to perform, and you can decide to finish by loading in the data. Once you do that, it will show you whether the operation was successful or if there was any error along the way. So I'm going to close this now, and when we refresh this now and open the tables under the employees database, we'll find out that we now have the employees table. Now, the next step will be to open a query. To open a query from this database, so we'll just right click on the employee DB, open a new query, and then to interact with the table, say, okay, viewing the table. To do that, we just run a quick check to select all from the name of the table will now be employees. Now, this will allow us to get a view of the data properly. Now we see that we have exactly 1,000 rows and about 17 columns. Now, from here on, having loaded the data, you can now go ahead to start to answer the questions that we have. I mentioned earlier that for your SQL query to be optimal, it's important to always include comments. It's important to always include comments. Comments will help us understand what it is you are doing, the question you are trying to solve. So for each of the questions, we are going to be putting them as comments by simply going back to the brief and then copying the question, Ctrl+C, you come back to your query and then paste it as a comment. we paste it as a comment. So that way we'll be able to know, okay, this is the question you are using this query to answer. This is the question you're using this query to answer. So the first question says, how many departments are there in each? How many employees are there in each department? Meaning we want to know how many employees each department has. Now, I mentioned it before during the course of our classes that when it comes to SQL, I think the biggest skills that you put to test is your problem solving and your critical thinking soft skills, because that the code runs most times does not mean it's the right one. So that means you have to think critically to figure out what code best or what query best answers a particular question. Now, for this, the question is how many employees are there in each department? The question is how many employees are there in each department? We have the department column. So we're going to start with select from the name of the table, which will be employees. And then we are going to select the department column. So for this, what aggregation do you suggest that we will perform here that can answer this question? What aggregation do you suggest that we perform here that can answer this question appropriately?
Count.
What aggregation do you suggest? Okay, count of what?
Employee ID.
Okay, count of employee ID. Very good. Very good. The count of the employee ID. Okay, so we're going to do a count. Open this, and then we'll put in the employee ID. And we alias it and say count as total employees. Now, from this, do we need a group by here? Do we need a group by here? If yes, what are we
Yes.
grouping by? What are we grouping by?
By department.
Okay, so if you go group by, we have to group by the departments. That's very good. And then we order by, let's order it by the total employees, and let it give us the order in descending order. Okay, good. So let's run this and let's see if it answers the question. Okay, good. So we have 7 departments, and this is a count of all the employees. This is a count of all the employees. Now, for question 2, I'm just going to open a comment, go to copy the question, and I will bring it in. I'm going to upload both the brief and the data so that we'll also be able to practice before we have to tackle the final project. The second question says, what is the average age of employees in the sales department? So I'm going to run the select all from the table. Okay, so we have the age column. We have the age column. Now, for this, first things first is, before you start writing the codes, understand the question first. But okay, what are the columns that I need? What are the actions that I have to perform? From this, we can already denote that we are going to be needing the age column and the department column. And we are most likely going to have to use an average function here as well. So we're going to start by selecting from the employees table. So here we need, let's even just do the average age. Let's do the average of the age. And let it be the average of sales staff. Let's say the average age of sales staff. Now, here, we can just input. Do we need a group by here? Do we need a group by here? From looking at this query, do you think we need a group by?
No.
Okay, if you're saying no, why? Breakthrough.
No, probably you can use probably where, I don't know. So
Okay,
where
so where what?
departments because sales. We're all looking for sales, so
Okay, good. So this would be where the department. This would even already where the department equals sales. Okay, good. So if we run this, we should have the average age. Oh, I didn't highlight this completely. We should have the average age as 43. We should have the average age as 43. Now, you see, I'm spacing the codes evenly. When you are writing yours, you should do the same as well. Let your codes be properly spaced. Let them be well written as well. Now, for the third question, don't worry, we're not going to take too much of our time this evening. When we go over this, we'll take questions at the end of this, and then the project is going to be sent out. And is that who are the top 5 highest paid employees in the company? You look at the table again, you see that we have the annual salary column. The annual salary column. The question says, who are the top 5 highest paid employees in the company? Is someone trying to ask a question? Okay. So for this, we're going to be needing a means through which we can identify the employees. We are also going to be using the top function. So for this, we are going to say select top 5 from the employees table. And then it will say we can use either the employee ID or the full name, any of the two, because these two columns serve as identifiers for each employee. So let's select the top 5. Let's do both the employee ID. Let's do both the employee ID and the full name. Both the employee ID and the full name. Then we'll also select the annual salary because we want to find the top 5, the annual salary. Now, this is where it then gets interesting because if we run this like this, we are only going to get 5 employees and their salaries. So this means order by will still have to come in here. Order by the annual salary in descending order. In descending order. So the moment we get this right and we run this, look at the query with the answer we got before. Look at what this is going to look like now. So based on the annual salary, these are the top 5 employees. We have both the employee ID and their. You saw that the query before, it actually did run, but it wasn't correct. And that's why I mentioned before. Keep in mind that because your query or your code is running does not mean you have the right answer. So do you have any questions, or I can move on to the next question? Don't forget we are tackling 15 questions.
Sorry.
Okay. All right. Thank you.
Please, can we run it again? Like without the order by?
Okay. So without the order by, I'm just going to highlight this. and run it from the from. Can you see the result? When I was explaining top, I said top just limits to a particular order. It just limits, okay, top what? It will give you whatever number you insert, whether 3, whether 5. It will limit your results to just 3, to just 4, to just 5. However, where the work comes in is in order by. If we wanted the least paid now, our order by will be ascending. That is from the lowest to the highest. But because we want the highest, our order by will be descending. That start from the top most pays from the data. So I hope you understand that now and there's no mix up.
Yes, sir. Thank you.
All right. So moving on from this to the fourth question within the data. Moving on from this, I'm going to copy the fourth question from the brief and paste it. So the fourth question says, what is the distribution of employees across different genders and ethnicities? I'm going to run the select to view the table again. Okay, so we see we have the gender column, the ethnicity column. We want to find how the staffs are distributed across different genders and ethnicities. Now, for this question, we are going to be needing, number one, we know the columns we'll be needing, gender and ethnicity. And we are also going to be needing a count because we want to know how they are distributed. So we'll start by select from the employees table. Of the employees table, we are then going to select the columns we need. We can do gender first, and then we'll do ethnicity as well. After that, we can then do a count, and we can just say count everything that you find, or we can also use a count of employee ID as well as total employees. Now, for this case, we are going to be needing a group by because we have selected other columns with an aggregation. So we're going to say group by the other columns we've selected in this case, which are gender and ethnicity. Gender and ethnicity. And then let's just order the results. Let's order it by the total employees in descending order. So I'm going to run the query without the order by and with the order by. So this is the query without the order by. Okay, so we can see each gender across different distributions, but look at how the result is ordered. But if we do the order by, if we include the order by, you see that the results will be ordered from the highest to the lowest. And I think this is easier to comprehend. So we're going to keep the order by for the sake of the arrangement. On to question 5. It says, how has the average salary changed over the years? How has the average salary changed over the years? I'm just going to paste the question. And then select the, okay. Now, we don't have any column that contains year, that is called years here. However, we do have a column that contains dates. We have a column that contains dates. We have the hire date and we have the exit date. Now, when this means that we can extract the year, just the year from any of these columns, particularly the hire date. And I mentioned other date functions, just similar to Excel, that we have the year, the day, the month functions that we can use on dates to perform date manipulation. Now, so this means we're going to select from the employees table, and then we'll go. Firstly, we need to firstly extract the year. So we go using the year function from the higher date. We want to extract the year from there. Now, let's now alias it and call it years. Then, we want to perform an
Please, I want
average.
to ask a question.
Yes, please go ahead.
Okay, number 4, like the count star. Why didn't
Okay.
you do it like count employee ID? Why is it not like that? I don't
If you do it
So-
as count employee ID, you're still going to get the same result here. If you do it as count of employee ID, you're still going to get the same result.
Oh my God, the network, I can hear you very.
Okay, can you hear me now? Hello? Can you hear me now?
Yeah, I can hear you now. I can hear you now.
Okay, I said if you used count of employee ID here, you will still have gotten the same result. Don't forget that the employee ID is also a unique identifier. Any column that contains unique identifiers, you can use it as a count or when you need a count of other columns.
Okay.
Yeah.
Okay.
All right. So from here, we're trying to find how this average salary has changed over the years. So we've used the year function to extract the years from the higher date. Now I want to perform an average of the annual salary. An average of the annual salary. And let's call this average salary. Now, here, we are going to need a group by because we have another column with an aggregated column. So this would be grouped by this, the year and the higher date. I said whenever you are grouping by a column that you have applied any other function that is not an aggregated function on, you need to call out that function. You cannot call out the alias. If I want to say group by years now, yeah, it's not going to work. If I try to run this now to say, okay, I'm grouping by years here, can you see that? In fact, it's even already giving me an error that there's no column called years. So in this case, we have to call it out with the year higher date. That is the function that we applied on it earlier. And then we can decide to order by. In this case, let's firstly run it without the order by and see what we should order by. So let's execute this. Good. Now, you see how the result looks like. We have the years randomly arranged and the values randomly arranged. But the question says, how has the salary changed over the years? So what do you suggest that we should order this query by to get it to be optimal for this question? Any suggestions what you think we should order this query by?
I think it should be by year.
Okay.
Please,
Do
I
we
have a
agree?
question, please.
Okay, please go ahead.
Can we use the months and years together with the dates, like the full dates, like year, year, month, and month, year, month, and date,
If you want to call out
like where
the
you use
if you want to call out the
like
month, you're going to have to select the month function on that particular date function and call it out as months as well. But for the sake of this question, I'm sticking with just the years. I don't know
okay, well
if
noted, well noted. Thank you.
okay, all right. So I'm going to be going with the first suggestion that says we should order by the years. And now for order by, you can use your alias, which is the years. Now, if we decide to run this, we will see the progression of the average salary from the first year up until the last year. So that's a very valid suggestion. Now, this is supposed to be a monetary value. So that means we are not supposed to have more than 2 decimal places. Now, how do we round all of these values up to 2 decimal places? For that, for this average, we are going to use the round function. The round function. I wanted to wait till this point to explain this. Now, what the round function does is that you use it to round up a particular numerical value to whatever decimal place. So we're going to say round on this average salary. Put a comma and then specify that we want it in 2 decimal place. Whatever decimal place you want after this average has been performed, you indicate, okay, round whatever happens here to 2 decimal places. If you want it in 3 decimal places, you put 3. If you want it in 4, you put 4. If you want it in 1, you put 1. All the round function does is that it rounds up whatever value you are working with to whatever decimal place you specify. So I put 2 here. If I run this now, round is going to round up the average salary all into 2 decimal places. I hope you can see that here now. So I don't know if there's any question on this before we proceed. Please ask a question so that your project will be easier to work on. Any questions? If there's no question, it means I can move on. All right. Now, from here, moving on to the 6th question. I'm just going to copy the question from the brief. I'm going to paste it here. It says, which department has the highest average bonus percentage? Now, let's not forget, I mentioned at the start of all of this that the percentage is not a recognized data type here. Meaning, if we're going to work with, now, take for example, let me show you what this means. Okay, which department has the highest average bonus percentage? Okay, we have the bonus column. We can decide to just go select from employees. We can select our department, and then we can do an average of the bonus column and call it and alias it as average bonus. Now, highest. So what we're going to do here is, since it is asking for the highest, we can either decide to use an order by in our result. Say, okay, order it. Firstly, we group by. So let's group by department. And then we can decide to run it this way. So say order by the average bonus in descending order. And now we can decide to limit it to say top 1, because we want to see the department that has the highest average bonus percentage. This will show us all the departments. If we don't include top, it will show us all the departments. Now, look at what will happen here. If you run this code, it's going to give us an error. Why? Because the bonus in this data has been stored as text data type. That's varchar. It has been stored as a text data type. Meaning we cannot perform an average aggregation on it. Now, how do we then write this query in such a way that we'll be able to remove the percentage from these values and calculate the average bonus? How do we get the percentage of this column and be able to perform this calculation? Now, this is where the cast and the replace function come into play. This is where the cast and the replace function come into place. If you remember, when I was talking about text functions, I mentioned the replace function. That is like find and replace in Excel. You use it to look for a specific value within a column, and you use it to replace that value. Now, for the cast function, I mentioned it when I was talking about DDL commands, that we use it to change the data type of a particular column within a table. So we want to perform two actions here. Number one, we want to change this bonus to a float data type. We want to change it to a float data type. That's number one. Number two, we want to replace these percentage symbols. We want to remove them. Now, if we want to do that, first things first, let me delete this average bonus. This is what the code is going to look like. We're going to say, now we're going to put both the average, the cast, and the replace functions together. What we want to find is the average. Now, we want to change the data type, and then we want to replace a value. Now, let's take it one after the other. The replace function is what will work first. The replace function will work first to say, okay, within the bonus column, what am I looking for? Find the percentage sign, replace it with what? Replace it with nothing. So I'm just going to open a double quote and close it. That don't put anything there, just nothing. Now, with this, replace has done its own work. Next to cast. Cast is going to change the data type. Okay, after replace has removed the percentage, we want to change it to a numeric data type. So we go cast as, that is, as what data type? We go cast as float. That is, after the percentage has been removed, cast the data type as, you can decide to cast it as integer as well, as a number. The reason why I'm casting it as float is because if we perform the average, we most likely will get a decimal. We most likely will get a decimal for the average. So a float data type will be most suitable in this case. Now, cast has done its work. Then the average. When cast has done its work, average should then find the average. So I'm going to close the bracket for average and then say as average bonus. Now, if I run this, the bonus column will be usable for a calculation. We'll be able to use it to calculate because we have been able to successfully remove the percentage and also change the data type for the column. However, if you look at the way these values are showing, we want to get them properly. That is, we want to round up. I think it will be safer to get it consistent with the sales and round it up. So we're going to go after average. Let's round coming. Now, meaning there's still one more bracket to come after this. Round as how many decimal places? 2. So we close the bracket for round. Now, for the sake of it, we have combined 1, 2, 3, 4 separate functions, all for one answer. Just the same way in your Excel now, take for example, you can combine if, or in fact, even the mathematical functions, your count if, your sum if, and all those guys, they're a combination of two functions, the aggregate functions and the conditional statement if. Now, what this will do is that it's going to round up the result and leave it in 2 decimal places. With this, we can see that the accounting department has the highest average bonus. If we now want the result to be just the accounting department, we can go select top and go top 1. So if we run this, we will see just the department with the highest average bonus. I don't know if there's any question before I proceed, because we are still going to have to work with the bonus column as we go on, and we'll be needing this again. So please, if you have a question, ask. If not, I proceed. All right, so I'm good to go. I should proceed. All right. So I'm going to proceed to the next question. I'm going to copy the next question, which is going to be question 7. We still have 8 questions to go. Now, for question 7, it says identify employees who exited the company within their first year. Identify employees who exited the company within their first year. Now, we're going to select from employees. We see we have the hire date and the exit date. We have the hire date and the exit date. Now, what we want to do here is that we want to find all the employees that left the organization within the first year of employment. Meaning, in this case, we are going to be needing both the hire date and the exit date. So for this, we are going to select, we want to find employees. So let's select all the employees. Let's say select all from the employees table. And I will explain why I selected all when the query shows up. Select all from employees. Now we'll say where the date difference. I explained the date difference for the date diff function when I was explaining date functions. I mentioned to us that the date diff function allows us to calculate the time range or a periodical range between 2 dates. It could be 2 columns that contain dates. So in this case, we can use date diff to find a periodical interval between 2 dates. This is the syntax: the interval, the starting date, the ending date, and it returns whatever it is that we want. Now, in this case, if we decide that the interval should be in years, how about people who didn't spend up to 1 year? That's going to leave them short. If we say year, and we say, okay, the starting date should be from the higher date column, and then the ending date should be from the exit date. Don't forget, we're using a where, that is where the date difference is, let's say, less than or equal to 1. You know, we are using year. If we run this, this will give us employees, all the employees who were in the organization and left within the period of 1 year. Take this first person as an example. This person was hired March 14, 2022, but left July 17, that same year. So this works. And we can see that we have 23 employees that left within their first year. Another way to have answered this would be to use the day interval, and say where the date difference is less than or equal to 365. That is, this is a year or less, but in count of days. So I hope you understand that. I don't know if you have any question. I don't know if you have any question. Please ask your question. If you have a question, please go ahead, speak, ask your question. And I hope I'm still audible, please.
Yes, sir.
Breakthrough. Okay, so no questions. I can move on.
Sorry, this function. Why did you
Yes.
use greater than or equals to 1? Sorry.
I use less than or equal to 1 because the question says identify employees who exited the company within their first year. So what I'm trying to say is this date difference should find the year function, and the where that returns the answer should only return years where the difference is less than or equal to 1. So that will mean that the difference between the hire date and the exit date must not be more than 1 year in relation to the question. So I hope you got that.
Yes, thank you.
All right. So moving on to question 8. Moving on to question 8 from the brief.
Sorry, you did not
So
run
for
the query.
I did run it already. Can you see? Oh, okay.
Okay, okay.
This is the result here. So for this, question 8 says calculate the total annual salary expenditure for each business unit. You can see that we have a business unit column. All we want to do here is that we want to find the sum of the annual salary for each business unit. So this should be straightforward. I'd like someone to volunteer to write this question to write this query for us. This query. So what's this query supposed to look like from the question?
We use sum function.
Okay, so the order in which the query is supposed to go. Select from.
Select from
Okay. The employees table. All right, I'm
employee.
with you. So what are we selecting?
Go back to select.
Okay, I'm on select already.
Sum function.
Okay.
Annual
Are we
salary.
okay? Are we summing first from the question? What other columns do we need? That should be the first thing that we decide. Okay, are we selecting another column with this?
Business unit.
Oh, okay. So we're selecting the business unit column, and then the sum can come in.
Network.
The sum can come in, and we are summing up the annual salary as,
Salary.
let's call this
Sorry,
the
I don't
total.
even know. Maybe you can hear me. My network.
Yes, I can hear you, but your network is breaking. So moving on from that point, moving on from this now, definitely here we already know we're going to be needing a group by. So we group by the business unit, and then we order by the total salary. Let's order it in descending so we know the from highest to lowest. So if we run this and execute it, this will give us each business unit and the sum of their total salary. So well done. Thank you so much for helping with that. I think this is quite straightforward, and we can move on to the next question. Now, the next question says, what is the average age of employees in each city. We're going to view the table. And then, okay, we have the city column, we have the age column. We know we're going to be needing both of them here. I think this is pretty straightforward too for us to tackle. So we'll just go select. The columns that we need here will be city, and so go from employees. So we select the city column first, and then the average, we need the average of the age. The average age as, let's call this average staff age. Now, what are we grouping by here? We are grouping by what? What are we
By the
grouping by here?
cities.
Yes, thank you. All right, by the city. And then we can decide to, if we run it this way, we'll see that maybe we need to include the order by the average staff age. If you don't specify an order, it will sort in ascending order automatically. Whereas if you want to go from the highest to the lowest, you have to specify that you want it in descending order. So if you execute this will then give us the highest average age and the city, and the lowest average age and the city. So that was pretty straightforward. Moving on to the next question, which is question 10. So the next thing we have to do is to determine the average salary for each job title. The average salary for each job title. So we see we have the job title column, and this is just going to be straightforward for us. We're going to be firstly run the select and the from, and then say from the employees. First things first, decide the columns you need, the aggregations you are going to perform. So in this case, we select the job title column and then the average of the annual salary as well. The average of the annual salary, let's call it average staff salary. Now, we know we need a group by here because we've selected another column. So I'm going to group by the job title, and let's also sort it by the average staff salary, which is the alias name. Now, if we run this will give us the average pay for each job title. This is a pay column, so I'd also, like to suggest that first things first, we round this up. Now, if we want to round this up to 2 decimal places, what do we do? If we want to round this up to 2 decimal places, what do we do? We want to, okay, so where's the round function coming into? Where is it coming into?
Before average.
Yeah.
Okay, good. So we'll go round. Before average, we'll go round. And then we'll specify with the comma that we want 2 decimal places. Close the bracket. Now, if we run this, we should have that column returning just 2 decimal places. And we can decide to order this in the right order. So we can see that the vice presidents have the highest average staff salary. Now, moving on to the next question. Now, for this case, we are going to be needing the bonus again. So it says compare the average bonus percentage between different departments. Compare the average bonus percentage between different departments. We want to compare the average of the bonus between each department. So in this case, We know we are performing an aggregation, and we know we are going to be needing the department column. So let's first start with select from the employees table. Once you selected the table, then we can, okay, say we want the department. We want the department. Now, don't forget that I mentioned that if we are going to need to use the bonus column, because it contains percentage, we're going to have to round, average, cast, and replace. Now, if you've done that before, a simpler, or should I say a more effective way, would be to just go and copy a scenario where you've performed that function before, to copy it and come and use it where you need it again. Like that is, if you've done something like that before in the past, instead of rewriting, you can just copy the portion of your code that performed that action and come and use it again. So it will work as it did in the other instance without having to rewrite that portion of the query again. So that's a more effective way. And in this case, we are going to group by the department and then order this by the average bonus. So if we run this now, this will give us the department and their average bonus from the lowest to the highest, because we didn't specify the order here. And by default, order by groups in ascending order. I hope you understand that.
Yes.
All right, thank you. Moving on to the next question. This might be a little tricky. It says, how many employees have left the company? How many employees have left the company, and what is their average tenure? We want to know how many employees have left the company and the average tenure, that is on average, how long do they spend in the organization? So first things first. First thing we need to know is, okay, how do we plan to get, before we even start, because I think this question is like 2 in 1. First things first, how do we find the employees that have gone? Secondly, then their average tenure. Now, this is how we are going to answer this question. We see we have an exit date column, meaning anybody who has an exit date, a valid exit date here, has left the company. Anybody who has a valid exit date here has left the company. So that means we can find out staff who have gone with information in this exit date column. So in this case, what we are going to do is that we are going to select all the employees. We say we select all from employees. Just hold on, stay with me. Now we're going to select a count here. We say select count of all as, don't forget, I said we can also use employee ID here. As long as it's something we can use to uniquely identify staff, we can use it. So here we can use employee ID as well. We can say, okay, count all the employees. That is, let's do total employees. Let's alias it as total employees from the employees table. Now, or we can just say total employees gone. Now, we want to find staff that have gone. So in this case, we are going to say where the exit dates The criteria for us knowing that you have gone is that you have a valid exit date. So say where the exit date is not null. That is, as long as the exit, you have an entry in the exit date column, be counted as an employee that has not gone, that has gone. Now, this has answered part A of the question. Now, we also need to find the average tenure. That is okay. Let's find the average number of years that these people that they spent here. To do that, we are going to need the average function and the date difference function. Because if we want to know how long they've spent, it means we have to find the difference between when they were hired and when they left. Okay, when were you hired? When did you leave? So in this case, the average function, we have to work with the date difference function to give us what we want. What the date difference function is going to take care is the year, then the first column, that's the starting date, will be from the higher date column, and then the ending date will be from the exit date. So we're going to close two brackets because we're using two functions, the date diff function and the average function. And we're going to ask you to save this as alias this and call it average years at company. The alias that you give your aggregations also help with your understanding that when we run the query, we see what you were trying to do. So now, let me even try to break this. So maybe it's not too long for us. So let me break this to another line. Now, if we run this query, what this will do is that it will return both a count of employees that have gone and their average tenure. So we have a total of 103 employees that have gone, and the average tenure that they spent at the organization is 5 years. Please, if you have a question, ask, because we have just 3 more questions to go. Okay, so rightly so, moving on to the next question, which is going to be question 13. Now, it says to identify employees who have been with the company for more than 10 years. This is quite simple. All we have to do is to select all the employees from the employees table where we need the date difference function now. Say where the date difference between the higher date and the exit date is greater than 10 years. We say the year, the higher date, the exit date, where the difference between both of them is greater than, don't forget, it says more than 10 years. So that means we cannot do greater than or equal to 10. We have to do greater than 10. Say greater than 10. If we run this now, this will give us all the employees who have been with the company for more than 10 years. Meaning, if you've been with us for more than 10 years, we'll see it here. And we see that we have just 15 employees. Now, let's confirm that. Take a look at this now. Hire date 1999, exit date. So these are the staffs who were with the company for more than 10 years. I don't know if we have any question on this or we understand and I can move on. Okay. So moving on to question 14. I hope I'm still audible. I hope you can all still hear me, please. Adekunle, breakthrough.
We can hear you.
All right, thank you, Oladamila.
Yeah, we can hear you.
All right, thank you, Tenike. Now, we are back to that rugged bonus column again. We are told to calculate the average bonus percentage for employees under the age of 30. Now, first things first is
Yes, sir.
we need we need just the average bonus, and we'll use the where clause
Yes,
to
sir. Yes,
filter
sir.
for where the age is less than 30. So let's firstly put select our from and the where to say where the age is. So here, if I may ask, from this question, are we doing less than or equal to 30 or less than 30? From the question we're about to answer, are we doing less than or equal to 30, or we're doing,
Less than 30.
why are we doing less than
Less
30?
than 30.
Why less than?
Under the age. So
Yes, less than is correct. The question says under the age. I just wanted to be sure we're not guessing. Now, what are we selecting? We are selecting the bonus. If we are using bonus, then we know we are needing this. So we come to copy it again. Bless you. So we know it's average bonus. This will give us the
hello?
average of the bonus. We are still with you. If you're trying to say something, we are still with you. We can still hear you. So we are to, if we run this, this will give us the average bonus for, I didn't select the first time. This will give us the average bonus for staffs that are under the age of 30. Now to the final question, which is question 15. Says to compare the distribution of bonus percentages across different ethnicities. We want to now compare the distribution of bonus across different ethnicities. Now, if you see any question that asks you to compare without specifying the kind of aggregation that you should perform, a way I'd advise to go about it is this way. Find the mean, find the max, and then find the actual value. That way, you'll be able to compare. You have the lowest, the highest, and the actual value. Then, okay, where does this fall in between this? So first things first, we're going to select, we need the ethnicity column here. We need the ethnicity column. Let's go from the employees table. Now, after the ethnicity, I've said, okay, they said we should find the bonus percentage, meaning we need this. We need this function that we used for the bonus before. So I'm going to put this on another line just to make it readable. Now, if we want to find the mean, that's the minimum bonus. And if we want to find the maximum bonus as well. Now, don't get me wrong. If we run this, all we have to do is group by the ethnicity, and we would have an answer. Now, okay, for each ethnicity, this is their average bonus. But the question says to compare the distribution across different ethnicities, and it does not even specify that we're supposed to perform an average. So what we're supposed to do in this case, to be able to get a proper answer, is to find the highest, the lowest, and the midpoint. And to do that, we need mean, max, and average. So for this case, after we find the average, we are also going to find the mean and the max of this same bonus. So all we have to do is, now we are not finding so this is what the formula will look like now. We are no longer finding average. We are not finding average. So we'll delete the bracket for average and have just round cast, and replace. We have just round, cast, and replace. In fact, I prefer that we write this again from start. Now, let's do the mean first. So we'll say the mean. It will now be no more average. So it will be mean, cast, and replace. The bonus, we are finding the percentage sign, replacing it with nothing, and then cast is changing the data type to float. In this case, we are just calling it as the minimum bonus. Now, there's supposed to be a comma after this because these are now two separate columns. Now, you can then copy this since we know the next column will be the max. And instead of using a mean, we'll change this to a max. Put a comma after this because we want 3 columns. And the alias will then be maximum bonus. So if we run this, this will give us the mean, the midpoint, and the max. That way, we have a comparison of the distribution. We have a comparison that is, okay, from the lowest point to the midpoint and then the highest point. So this properly answers the question now. I don't know if we have any question because we are on the last question. Any question? Okay. In the absence of questions, now, this week is going to be for 2 things. Number 1, for the project, for the SQL project, and number 2, for us to catch up with whatever class it is we have missed in the past. Now, for the project, I'm going to be sending us the data set we are going to use, that is, that we're going to load into SQL Server, and also I'm going to be sending us the brief for that data set. So we have the questions and the data set. Now, we have just 1 week, as we're also going to be meeting later this week. Just a submission of our project will be done on the classroom. There will be a deadline for submission. And after this week, we're going to be having our portfolio building session and also our CV review session. I want to say that if you've not been working on your project, if you've not been documenting your project, you're not going to have anything to share, to build, to use, to put in your portfolio. So that means the portfolio session is going to be also like a reward for people who have been working on their projects and also been following on in the classes. So once again, I want to thank everybody for joining the class today. I'll definitely be sending today's code across to us. I'll be uploading it into the classroom and also the data set and the brief. And I wish us all the best. Enjoy the rest of your night and have an amazing week.
Yeah, thank you, sir.
Thank you.
Yes.